I'm gonna take a look at this one because I think it's really interesting. 2x plus 1,000 divided by x squared minus 3x minus 1. Okay, so check this out. If I were to graph this, and I'll tell you what, let's just go about doing this the straight up way that I taught you how to approach this. And the way I would say is, okay, you set this about equal to, and you let x go to infinity, which basically means that the only thing that's important on top is the 2x, and the only thing that's important on the bottom is the x squared. Cool? Now that will translate to 2 over x, which ends up being, 2 over x. So if I were to graph that, I know what the graph of 1 over x looks like. That would kind of look like this. So on the left-hand side, you're going to be coming from a negative number below 0, and you're going to be going up towards 0, getting closer and closer. And on the right-hand side, you're going to be coming from the positive side of 0, and you're going to get closer and closer to 0. Let's try graphing that and see what we got. It's 2x plus 1,000. All right, here we go. 2x plus 1,000 divided by, what was it, x squared minus 3x plus 1. Okay, all right. Minus 3x plus 1. I have no idea why this thing is not showing me the negatives, but anyway. Whoa, what does that graph look like? I can't see it. Let me zoom out a little bit. There we go, I see it. Okay. Now, what you would say is, look at the way I graphed it, is I said it looks like this over here. And it looks like this. But the way you guys are looking at this graph, you guys are thinking, well, wait a second, that's not correct. It actually is coming up from this side and coming up from this side. And I would say, no, it's not actually. As you go out further and further this graph on the left side goes from negative, or starts at below the 0 point and comes up closer and closer to the 0 point. And you can't really tell that over here. Now remember, I don't really care, when we're doing this end behavior game, I don't really care what the middle thing looks like, what the stuff in the middle looks like. All I care about is what the what's going on at the ends. So I'll tell you what, why don't I take a look at another graph right here. Let me go pull this up and say Wolfram Alpha. Let's go jump into Wolfram Alpha. I like using this site. This is my favorite graphing site, but this site right here kind of helps me out a lot. It was what, 2x plus 1,000 divided by x squared minus 10x plus 1. No, minus 3x plus 1. Was that it? Which one was it? Minus 3x minus 1. Okay, minus 1. So what you can see in this graph right here is they're going to rescale this thing so it's funky. And when I was looking at this, to be honest with you, when I first looked at this, I was confused. I was like, wait a second, what's going on? Because my graph looks very different from theirs. But when I pulled it up on Wolfram Alpha, I looked at it and I looked over here and noticed that there's a little blue spot right over here. I think that's really interesting. Also notice that when they rescaled it over here, and what I mean by rescaling is their scale's a little bit funky. This scale is perfect, like 100 units this way is 100 units that way. Their scale is that, like, they're really zooming in on the y-axis and they're making x-axis really big. But you can see this interesting effect. What happens is the actual graph drops down below the 0, and then it's on the left hand, you know, as you go further out in x, it starts off negative, and then it comes up towards the it comes up to 0. And you won't be able to see that unless you zoom out to x equals negative 1,000. And see, that's the problem here, is we're not zoomed out far enough. And even if we did zoom out far enough, it's really hard to see that effect. Apparently, it happens at negative 500. which you wouldn't be able to really tell by looking at that graph. But if I were to zoom in right there, it almost looks to me like, hey, this I can't really tell what this graph is doing. But here, let's see how far we have to zoom in order to see this effect happen. Well, that's pretty far in. Actually, I don't know if you can even tell with the graph, to be honest with you. I don't know if that gets small enough. Let's see how far we can have to go. Because this looks like it's a straight up horizontal line. Alright, by looking at this graph, to be honest with you, you can't really tell that it's doing this. But here, watch. If I click on here and I click on here and I drag this point, you could see that. All right, the x value is negative 4.99 and whatever, but look, the y value is 6 times 10 to the negative 11. So it's a really small number, but it's a positive number. It's getting smaller and it's getting smaller. Looking at the second number over here, the 2 times 10 to the negative 11, that's telling you the y value is a positive number. On this side, once you jump over here, the y value becomes a negative number, so you know that it crossed the y-axis, or the x-axis. Let me zoom out and kind of get back to where a normal view would be. And looking at that graph, you wouldn't be able to tell. So I think it's really interesting that, you know, some people try to not necessarily cheat, but they're trying to do these things, and you know, I mean, the math is actually correct. The way I taught you was correct, but looking at this graph, you can't really tell that that's the effect that you would see. So what I said was actually true, that it dips below the 0 axis and then comes up to the 0 from the negative side. And over here on the positive side, it's coming from the positive side and goes down to 0. That's exactly actually what I graphed. It's coming from below this thing over here. Now, what is it doing in the middle, and why is it doing that? Well, that's because something funky is happening, and I'm not asking you to graph what's in the middle. I'm asking you to graph the endpoints. Let me show you what's happening in the middle, though, real quick. If I were to factor this denominator right here, see this guy right here? If I were to factor that denominator, and I'll be honest with you, you can't factor it. There is no number that multiplies out to be 1 and adds up to be 3. So what you would have to do is you would set that equal to 0, and then you would plug it through the quadratic equation. The quadratic equation would give you two numbers, and that would give you your two asymptotes. So on my graph, my asymptote would probably be something like this and something like this. And what's happening is this graph is actually coming down from below 0. It's coming up. And then it bumps up this way, okay? And then this graph looks like this. So you're thinking to yourself, well, wait a second, isn't this middle asymptote that I see over here on Desmos a square asymptote? Here, let me just zoom out far enough to get back there. See, it's to the square power, and I would say no, actually there's two asymptotes, and what's happening here is this is bumping over an odd asymptote, and so it starts down at negative infinity over here, and comes up, and then starts down at negative infinity over here. And you don't see that effect on Desmos because maybe you haven't zoomed out correctly, zoomed out enough. If I zoom out enough, there you go. Clear enough, clear as day, you can actually see this bump. It just happens so far down at negative 805 or something like that, that you don't actually see what's going on over there. So here's my point: is you're going to try to use Desmos, or you're going to try to use some graphing calculator to, you know, I mean, to give you the answer for this, and the calculator isn't as smart as you. It's just going to show you what you need to know, but it's not going to really tell you the answer. The best thing to do is really just to trust the way I taught you, and choose this answer. So some of you guys were saying, hey, you got the wrong answer, and actually no, this is the right answer. The one with the black marks over here. It comes from. Oh, let me just redraw the right answer. So the answer is actually like this, like this. And I don't really care what's happening in the middle. I will care later on. We're going to do problems like that, but I'm going to probably give you a lot more intuitive, easier ones to look at. For now, I'm really just playing this what is the n behavior game that we're trying to do.